or sine of theta is equal to 0.922419. Sorry, sine squared. Sine squared.
Yeah, I didn't get either of the, I don't know, I must be doing it wrong. I broke it into parts. Oh, that's what I did wrong. Okay, I know what I did wrong.
All right. So these are, remember, these are values of x. X is sine squared. So now we have to solve for sine of theta. Well, take the square root. So we now have sine of theta equals, what's the square root of 0.03254? Pardon?
Can you repeat the question?
I have sine, x was taking a look at the first solution, x is equal to this. X is sine squared. So sine squared equals that. I'm trying to find sine theta, so I need to take the square root. What is the square root of that?
0.180388.
180388. Now here's the tricky part. If I have x squared equals 4, what does x equal?
2.
Or
Plus or minus 2.
so this is plus or minus 0.180388. The other one, sine of theta, is equal to plus or minus
0.96042.
So we now have 4 potential solutions here. Actually, we have potentially 8 solutions. Because there's 2 angles that'll give me the same value. There are 2 angles that'll give me a sine that's positive 0.180388. Your calculator will give you 1, but there are 2. If we go think back on a unit circle, if this unit circle has a radius of 1, call that x and y axes. This point right here, that angle there is theta. This is the point x, y. It is also the point sine of theta, cosine of theta. And it helps if I do that in the correct order. Cosine of theta, sine of theta. In other words, my sine of the angle, there's going to be an angle over here also that produces the same y value. Hopefully drawn better than that. So let's come up with our 8 solutions and start getting rid of the things that don't make any sense. So if sine of theta is equal to, let's get some room. So sine of theta equals 0.180388. Theta equals preferably in degrees.
10.392. Yep.
One of our angles, that's a possibility. That means it's being thrown 0 degrees is this way, so it's being thrown sort of at an angle like that. Or there's a second quadrant angle that also has the same base angle. No, that's right. I threw that on the ground for a reason. So I've got this 10-degree angle here. There's another angle over here in the second quadrant. So it's going to be 180 minus that. Or 169.608 degrees. Mathematically, one of those does not make any sense physically. If the sine of theta is equal to negative 0.180388, our angles will be negative 10.392 degrees or 190.392 degrees. Fourth and third quadrant. Yes?
I thought when we have like a negative symbol or positive symbol, it would either go from top to bottom, not left to right, or vice versa. So like when you go in a unit circle, like let's say the negative 1.80, that would go to the fourth quadrant, it was.
For cosine.
But for sine, it goes from, okay.
Yeah. Sine of theta is equal to positive 0.96042. Theta equals
73.827.
73.827.
No, 73.26.
70.26.
73.8.
Try this again. What is the angle?
73.82737.3739 degrees.
So what I wrote right there. So you got something different?
73.826, different from 5.
All right, so it's just that last decimal.
Yeah.
Okay. Close enough. Or, that's my first quadrant, there's gonna be a second quadrant, will be 180 minus that, which is 106.173 degrees, I believe. And then we have sine of theta is equal to negative 0.96042, which would give me an angle of negative 73.8227 degrees, or maybe 360 minus that. No, that is, so it would be 180 plus that, or 253.827 degrees. All right. That's the negative 73.827 degrees. I know that with sine, there's a symmetry about the y-axis, and so that means that the other angle is there. If this angle here is also 73.27 degrees, well, then the total angle is 180 plus that. All right, let's think about physically what we have right here and start getting rid of stuff. So 0 degrees is to the right. Our first quadrant angles, we got 10 degrees, maybe. We have 169 degrees. So is it possible that I can throw it in this direction and have it land over there?
No.
Unless source.
So that is gone. In the next one, is it possible that we could throw it at an angle like that and have it hit over there?
No.
Yes.
Is it? Oh, yeah.
Yeah.
Yeah, it is possible to throw things down and to the right and have it land to the right. What about if I threw it that way?
No.
And as we go on, it's the second and third quadrant angles just don't make sense. Because if I'm throwing it from the top of the cliff there, I'm either throwing it in first quadrant or fourth quadrant. However, two of these angles are wrong. I suspect it's going to be one of those and one of those is wrong. So we have to figure out which one is correct. Now, if we had solved for cosine, if we had solved for sine, sine squared is 1 minus cosine squared, and made that substitution, we would not be having this issue. But we're here. How do you determine which is the correct one? Oh, you're gonna love the answer. I assume you know it already. That feeling of joy is building up in you.
Gas.
Here we go. Wait. We're gonna do trial and
What'd you say?
We have to use trial and error, so like, yeah, since, hold on. Never
You
mind.
plug it in and then just see what you get.
But we've narrowed down to 4, at least I'm not doing every angle. So if we start with the first one, we get cosine and the sine, we figure out what those are. All right, let me take a moment to see if there's a simpler way. I don't think there is, but. Well, I will say, all right, here's the partial simpler way. I'm feeling very confident it's gonna be one of these is right, one of them is wrong. One of these is right, one of them is wrong. So if this one turns out to be right, then we can just don't have to check that. If it's not right, well, assuming we haven't made a mistake, then we know that one's it. So we really only have to check 2 and not make a mistake. Let's do it. Yes, Brigitte.
You said we would not have an issue if we did what instead of what we did?
When we did sine squared is cosine squared is 1 minus sine squared, and we plug that in. Previous one. Here, we said cosine theta is square root of 1 minus sine squared theta, and we substituted that in for, we plugged that in for cosine squared, or cosine here, to get this.
Yeah.
If we had instead done sine theta is 1 minus cosine, square root of 1 minus cosine squared theta, and made that substitution in for sine, you don't end up in as big a situation. You will end up with only 4, it turns out. Only 4 that makes, only 4, 2 of which will not make any physical sense.
I wish we could have done that.
You should have told us.
You know, I knew it was one or the other, and I was trying to remember which one it was, and so.
It's the cost.
While we're on this aside, you said you put this on a test.
Yeah.
Was it 151?
Probably 2 hours, 3 hours.
Yeah, it did not go well.
I
So
can't-
we're not doing it anymore.
It's been
If
an
I-
hour.
If I put it on a test at this point, I would say get as far as the equations you need to solve. So if you got it to one equation, one unknown, like right here, if you got this far, that would be enough. Because the rest is just an exercise in math. Actually, it's a good bit of math up to here too, but. All right, but let's actually come up with a solution. Now, some of you might be able to walk away and think, I can do this at home, but I need the closure. So we're gonna start out with that 10 point whatever. This is also a check because it's quite possible that we've made a mistake somewhere. All right, so if we're dealing with 10.392 degrees, so if theta is 10.392 degrees, that equals $39.344.
For cosine? Yeah.
If you're not getting that, either she was,
I put
I'm assuming if you'd been in radians, I think we would have gotten a very different answer. But if your calculator's in radians, who knows what you get. And this would equal,
what mode is your calculator in radians? So it should be in degrees.
7.215.
all right. So now, we need to figure out the time.
time to figure out if those were the right
Yeah.
angles? Okay.
Yeah, I told you, you'd love this.
On a test.
We would need to find the J hat because for I hat, we just need to find out the velocity is constant the whole time, right? Or do we need to
Oh,
find?
actually, okay, we could do it. We could use this to find time and then see if that works over here. Then, yeah, let's do it that way then. So I have 100 looking at. $100 is equal to 39.344 T. I'm using the third equation with the horizontal components. And so T is gonna be 2.5 something. And if this is correct, then negative 50 is equal to 7.215 times 2.542, again, using that third equation over there, but with the vertical stuff, minus 4.9 times 2.542 squared. Is this equal to negative 50?
It would be really funny.
Please be equal to negative 50, or close enough.
Actually, yeah, why am I even writing this?
What do you got over here? Negative 13.3221?
Yeah.
All right, so unless we've made a mistake, this is not the, 10.392 is not right. Which means that negative 10.392 has to be right. Let's do a quick double check, because if theta is going down there like that, this is still the same. This is now negative. So if theta is negative 10.392 degrees, that will be a negative. And now we get
Wouldn't that also be negative?
the cosine, the right hand, the I hat.
Yeah.
No, because if it's negative 10.392 degrees, it's being thrown down like that, so it's still going in the positive I hat direction.
So it's negative 50.0032.
Good enough. All right, one solution done. Now, I'm betting that the other solution is, since this is the negative, the other one is the positive of the 73 degrees. But let's double check that. So one solution, theta is equal to negative 10.392 degrees. The other solution, so let's let theta equal 73 point something. 8 to 6 or 7, 8 to 7 degrees. If that's the case, what is this? And over here. Let's find out how this works. So it's going to be in the air longer because the horizontal is not as fast. So 100 is equal to 11.142 T. And now let's plug into the other equation to see if we get a result we like. So this is, see, this one's going up, so this is 38.417 times 8.975 minus 4.9 times 8.975 squared.
Negative 49.9.
Yes. So our other solution then, that and that. In one of the cases, we are throwing it down at an angle like this and hitting 40 meters or 100 meters from the base. In the other case, we're shooting up like that. And so we'll have this path of up and down, and then, and those are supposed to meet down there. But I can't draw. And I'm assuming that having seen this and gone through it, you feel like you're just a little bit better of a person. And everyone else out there who hasn't seen this, just feel sad for them. Or better yet, say, hey, I got this really cool physics stuff I want to show you.
I did just send that to someone, just randomly, to see what their reaction was. Like this entire notes of paper.
Got a reaction yet?
No. I assume it's going to be sobbing.
The tears of, they can't believe they've seen something so beautiful as that. I assume that's why the tears are beautiful.
I don't know about that one.
Like if Galadriel had taken the Ring of Power, she would have been worshipped and all would have despaired. Questions?
That's not a question.
Well, I also understand class is almost over, and so part of the tears is that you're about to leave here and we won't see you again until Tuesday.
But exactly, you have to be on Tuesday, Wednesday, and then Thursday again, and then it's all over again.
It's just this
It's all
cycle
over.
of joy and sadness.
And then I have to do it next semester.
Well, then